So what you have when you have a complex fraction is you have two fractions inside of each other, where you have a numerator and a denominator. And inside, now first thing, let's talk about the domain. The domain, first the entire denominator, 5 minus 1 over x. That cannot equal 0, because the entire denominator of the fraction cannot equal 0. So I solve that, and I have 5 cannot equal 1 over x, or 5x cannot equal 1, x cannot equal 1/5. Now, you also have the two other parts, the two other fractions that are inside the numerator and inside the denominator themselves. And both of those give us that x cannot equal 0. So that would be the domain of this complex fraction. Now let's go ahead and simplify it. So to simplify, what we're going to do with this one is we are going to look at each individual term in these fractions. And if I do that, you can see that they both have two fractions in them. What is the common denominator between those two fractions? Well, it's the same. They both have the same denominator, so that common denominator is just equal to x. So I'm going to multiply this fraction, the numerator and the denominator, by x over x. When I do that, I am taking the x and multiplying it times both of the terms here, with the purpose of giving me this is 3x plus x times 1 over x, or 3x plus 1 for the numerator. I do the same thing for the denominator, multiply, and I would be left with 5x minus 1 over x times x, or just 5x plus 1. That's one technique that you can use for simplifying complex fractions. You take each individual fraction, whatever it happens to be, look at all of the denominators, and then multiply it times that same value over itself. And you can do that because essentially you're multiplying times 1. With this complex fraction, let's first go ahead and talk about the domain. This first 1/2, there's nothing in there and no variable in there at all, so I don't have anything there I have to worry about with the domain. Then in this second portion, remember, I'm only concerned if the denominator is equal to 0. So I know that x plus 5 cannot equal 0, which tells me x cannot equal -5. In the last one, the entire denominator of the fraction x plus 4 also cannot equal 0. So x cannot equal -4. So those are the only two limits that I have on my x values right now. Now, how are we going to simplify this? To simplify this fraction, because the denominator only has this one single term, I'm going to do this a little bit differently. I'm going to say this is my entire numerator, and then I'm going to divide this by everything that is in the denominator here. So I'm going to rewrite this. I can now write this as 1/2 minus x over x plus 5 divided by x plus 4. This goes back to the division where this stays the same. I change the division to a multiplication symbol, and then I take the reciprocal. So now I have 1/2 minus x over x plus 5 times 1 over x plus 4. And it's your choice of how you want to go through and do this, as far as if you want to distribute first or find a common denominator. I'm going to go through and just by order of operations, we're going to work on the inside first. I have to find a common denominator here. So my denominator would, the first fraction, I need to multiply times x plus 5 over x plus 5. And on the second fraction, I multiply that by the numerator and denominator by 2. Simplifying everything inside there, I have x plus 5 minus 2x all over 2 times x plus 5. I'm going to continue to simplify that. So now in the numerator up here, I combine my like terms, and I'm left with negative x plus 5 all over 2 times x plus 5. And when I multiply that times 1 over x plus 4, I just go ahead and make that negative x plus 5 all over 2 times x plus 5 times x minus 4. Now, I want to talk about this negative sign that's leading for the x. A lot of times we don't leave it this way. We need to factor out a negative 1. So I'm going to go ahead and factor a negative 1 out, and that would change that to x minus 5 all over 2 times x plus 5 times x minus 4. And when I have a negative that's written out front like this, I can leave it this way, or pull the negative all the way out and write it as x minus 5 all over 2 x plus 5 times x minus 4. And that would be the final simplification for that question, along with the domain that we had stated earlier. Okay, so this one's a little bit different because we are going to have limits on both x and y, because as I'm looking inside here, I have 2 different variables. So if I look up at the first piece, the first fraction, I have an x in the denominator, which tells me x cannot equal 0. For the second 1 over y, that also tells me that y cannot equal 0. But the big question here is, what do I do with the denominator, x plus y? Well, it's not as intuitive, but it's okay. What we do is we define them in terms of each other. So I say that x plus y cannot equal 0, and then I know that x cannot equal negative y. There are 2 ways to simplify this. I showed you both of them. I'll do both of them with this one. Type 1, or the first way, is to find a common denominator. And I do that with a common denominator of each piece. So, and in my denominator, that would be over 1. So my common denominator is just xy. Now, so I take the entire numerator and multiply it times xy, entire denominator by xy, which gives me 3 over x, and I'm multiplying that times xy. Then I take this next term, which is 1 over y, and multiply that again by xy. Put that over 1 if you wish. Then I go ahead and x over x reduces to 1, y over y reduces to 1. We are left with 3y plus x. In the denominator, I am just left with xy times x plus y. That's it. That's all you can do with that. Just keep in mind that you do have that domain limitations that we said about in the very beginning. The second way to go ahead and solve this is with turning it into fractions. So let's go back to the beginning. Method 2 says that I have 3 over x plus 1 over y, and I'm dividing that by x plus y. So to rewrite that, that means I take my numerator, which is 3 over x plus 1 over y, and I am dividing that, so I need to keep that in parentheses, I am dividing that by x plus y. Now, I keep the first term the same and leave that as 3x plus 1 over y. The division sign turns into multiplication sign, and that becomes 1 over x plus y. Now, what you have to do next is you have to find a common denominator. And that common denominator for both of them is xy. So I multiply the first term by y over y, the second term for x over x. And now I'm left with 3y plus x over xy. Now, just because this is xy and this is yx does not mean those are different. Those two are the same thing. I multiply this times 1 over x plus y, and we get exactly the same answer. The method you choose to solve this is completely up to you.